NASA wants to build an Arecibo-like telescope on the Moon. NASA is paying a team of researchers to develop a plan for a telescope on the far side of the Moon. The Lunar Crater Radio Telescope, LCRT, as the concept is called, would be a lot like the Arecibo telescope, which collapsed in December. A huge dish would collect radio waves from the cosmos and amplify them so that scientists could analyze the signals. The difference is that on the Moon, such a telescope would be shielded from the cacophony of radio signals that such a device on Earth would hear from all kinds of equipment and satellites. To build the LCRT, rock climbing robots would suspend a kilometer-wide dish inside a lunar crater. The telescope would be nearly 3 times wider than Arecibo, and its lunar perch would give it a much better view of the universe. Arecibo discovered the first known planet beyond our solar system, mapped Venus' surface, and detected a pair of stars that confirmed Einstein's theory of general relativity. However, the telescope was at a disadvantage. Earth's atmosphere garbles radio waves with a wavelength higher than 10 meters, so it blocked Arecibo's view of the earliest stages of the universe. Building a telescope on the Moon, far from atmospheric interference, would allow astronomers to finally see what they've been missing. This is at the stage when the first stars were being formed in the universe, or even before that when the first matter was formed but the stars hadn't been formed yet. Studying the early universe could help scientists understand the origins of dark matter, which outweighs visible matter 6 to 1. The LCRT team has already picked out a few craters on the Moon's far side that would be big enough for the telescope dish, each about 3 to 5 kilometers, 2 to 3 miles, wide. Now they have to figure out how to get the wire mesh structure into one of those craters. One potential plan is to land 2 enormous landers on the edge of the chosen crater, one carrying the mesh and the other carrying 20 crater-climbing duaxle rovers. The rovers from that second lander would lay out a series of guiding wires on which the first lander would roll out the telescope's mesh net. A second option is to use harpoons to deploy the mesh, though that would take about 5 months, and the robotic equipment would have to survive long lunar nights. In their first phase of research, Bondo Padiai's team picked out a few moon craters that could host their telescope and plotted out the ideas for climbing robots and harpoons. They also laid out the LCRT's scientific objective, gathering signals from the dark ages of the early universe and filtering out the cosmic radio noise of our Milky Way. In the current phase, the most challenging thing is actually designing a mesh that satisfies multiple different constraints. Those constraints include making a mesh base for the telescope that would be lightweight enough to launch aboard a rocket. The mesh would simultaneously have to be flexible enough to be deployed on the Moon, durable enough to survive dramatic temperature changes there, and still able to conduct radio astronomy. The team will also do more research into the ways to build this telescope, conduct some risk analyses, and lay out a work plan.